Welcome to EDU World Space.
In this question, we are given this situation. Car A is moving to the left at 55 meters per hour, miles per hour, 55 miles per hour at a constant speed. And so the acceleration is 0 and velocity in car B is traveling at 40 miles per hour with an
Here's a clean and professionally
tangential
formatted
acceleration of
presentation of the calculations shown in the image.
1,200
Application of the work energy
miles per hour
theorem,
square.
wet. From the
Okay.
work energy theorem, the force
Right,
F is
so we
given
need to
by
find
F
the
equals a frac
velocity and
text
acceleration
KE,
of
where
B relative to A.
KE equals kinetic
Okay, so to
energy,
do this
S
problem,
equals
the
stopping
first thing
distance.
we need to
If
do
I'm
is
given
always
for
to
object A,
write down
FA equals frac
the
100,000,
velocity and
0.10.
acceleration of
For
A and
object
B
B,
in
FB
vector
equals
form.
frac 225,
Okay,
1500
so
equals
BA,
0.15 text space end.
based on the
And force
given
ratio
question,
frac
is
FA,
given information,
FB
negative
equals frac
55
0.10, 0.15
I
equals
hat
fractional result. A
miles
box
per
frac
hour,
FA, FB. Would you like a PDF version of this
and
explanation?
BB is equal to 40 negative cosine 30 degrees I hat plus sine 30 degrees J hat. So you get 20 negative root 3 I hat plus J hat miles per hour. So the velocity of B relative to A will just be velocity of B negative minus velocity of A. Alright, so this is what you get. So we have 55 minus 20 root 3 I hat plus 20 J hat. Then if you evaluate the numbers, calculate the numbers out, you get 20.4 I hat plus 20 J hat miles per hour. Okay, so you calculate the magnitude of the relative velocity, get 20.4 square plus 20 square, and take the square root, and you get 28.5 miles per hour. And then the angle theta is arctangent the y component divided by the x component, and this angle is 44.5 degrees. Okay, so this 44.5 degrees, okay, this is 44.5 degrees velocity of B relative to A. Okay, all right, then next we do the acceleration part. So since car A is moving at constant speed, so acceleration of A is 0. So acceleration of B relative to A will just be, A by definition is AB minus AA, it will just be acceleration of car B. Okay, so we need to find the acceleration of car B. Okay, so given that car B is accelerating, is increasing its speed. Okay, so there's a tangential component drawn this way. This is 1,200 miles per hour square. Then we also have a normal component. This is 90 degrees, 60 degrees. Okay, and the normal component is going to be VB square over R. Okay. Okay, so just write down the magnitudes. Okay, the normal component is VB square over R. Okay, VB is 40 miles per hour square, and then you divide by 0.5, you get 3,200 miles per hour square. Okay, so using this diagram, so we can write down the acceleration of B in vector form. So we have 3200 cosine 60 degrees minus 1200 cosine 30 degrees I hat plus 3200 sine 60 degrees plus 1200 sine 30 degrees j hat. Okay, calculate the numbers out. You get 561 I hat plus 3371 j hat. Okay, miles per hour square. Okay, so the relative acceleration of b respect to a would just be the magnitude of the acceleration of b. Okay, so 561 square plus 3371 square root using Pythagoras theorem, and you get 3420 miles per hour square. Okay, and then the angle theta, the direction arctangent the y component, arctangent of the y component divided by the x component, you get 80.6 degrees. Okay, so just draw the diagram out. 80.6 degree will look something like this. Okay, this is acceleration of b relative to a. Yeah. So just boxing up the answers. Okay, so this is the magnitude of the relative velocity and the direction of the relative velocity in with the diagram. Okay, and then this is the magnitude of the relative acceleration, and then this is the direction. Okay, and so that's all for this question.